Alright, so far we've explored the very basic definition of a limit, which is basically asking what the value of a function will be as we approach a certain point, wherever that point may be, infinity, x equals 3, whatever. So now let's take a deeper look at the definition of a limit and what makes a limit valid. So for a limit to be valid, it needs to be approaching the same point from the left and the right. Think about it like this. You're at a basketball game and you see a player shoot. You see the ball go up, 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 up. Right as it's going through the hoop, you blink and you don't see it go through the hoop. You open your eyes back up and then you see it fall down from below the hoop. Now, you can't definitely say that the ball went through the hoop because you didn't see it happen. But you can evaluate and see that it came very close to the hoop, and then the next time you observed it, it was coming out of the hoop. So you can assume that the ball went through the hoop. Now let's look at an example of this in limit form and something you would see on a math problem or on a test. So here we have this piecewise function right here. As you can see, it's half x from 0 to 3, half x again from 3 to 6, and then x squared when x is less than 0. So we can see that the function is defined from all the way over here to the point 0, all the way up until the point 3. We have a discontinuity, a little hole, as you guys may know, and then the function just keeps going from there. Technically, we can't say that the function at 3 is equal to 3 over 2 because it's not defined. But we can evaluate the limit and see kind of what the function would be if it was defined at 3. So we can see here that from the left, as we approach x equals 3, our function gives us a value of 3 over 2. And then when we approach 3 from the right, we can see that our function also kind of gives us a value of 3 over 2 or 1.5. As we keep going through the material, you'll see how we just did relates to determining if a function is continuous at a certain point or not.